All right, so today we're going to be computing with scientific notation. So that's adding, subtracting, multiplying, dividing. Yeah, so example one, scientists estimate there are over 3.5 times 10 to the 6th ants per acre in the Amazon rainforest. It's a lot of ants, okay? I'm just telling you that right now. We don't have any statistics on the number of uncles in the Amazon rainforest, but I imagine it's probably in the same ballpark. All right? If the Amazon rainforest covers approximately 1 billion acres, find the total number of ants, right, in scientific notation. So here's what we have here, all right? So if I have 3.5 times 10 to the 6th ants per acre, okay? And I have 1 billion, okay? 1 billion acres, all right? What I'm going to want to do here is I'm going to want to convert 1 billion into scientific notation. I'm going to make that 1 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have 1 times 10 to the 9th, okay? So let me erase all this. All right. 1 times 10 to the 9th. Okay. So if we take 3.5 times 1 times 10 to the 9th. Okay. If we take 3.5 times 1, that is 3.5. And then if we take 10 to the 6th times 10 to the 9th, it's almost like we did some wait, is that multiplying monomials, same base? 10, 10. Whenever we multiply monomials with the same base, we add the exponents, right? So 6 plus 9 is 15. So we have 3.5 times 10 to the 15th ants in the Amazon, okay? So that's a lot of ants. All right, 3.5 times 10 to the 15th ants in the Amazon, that's what we end up with. If you're curious, I mean, 1 times 10 to the 9th is billions, so I believe that we're talking quadrillions. 3.5 quadrillions, okay? So that gives us our answer to that one, all right? Neurons are cells in the nervous system that process and transmit information. An average neuron is about 5 times 10 to the negative 6th meter in diameter. A standard table tennis ball is 0.04 meters in diameter. Now, how many times as great is the diameter of a ball than a neuron? Write your answer in scientific notation. So, run it back. We got 5 times 10 to the negative 6th. And we have 0.04. So let's go to our handy dandy board here. 0.04 is in standard form. I don't like that. Let's fix that. So I'm going to move it 1, 2. Okay. I now have 4 times 10 to the negative 2nd. That's something I can deal with a little bit better. Okay. So I have 4 times 10 to the negative 2nd. And since that's a larger number, I'm going to take that and divide it by that 5 times 10 to the negative 6th. Now, split this up into 2 problems. 4 divided by 5 gives me 0.8. And then that gives me times 10 to the negative 2 minus negative 6, which would be 4. But here's my problem. If you remember back to yesterday, this first number needs to be greater than or equal to 1 and less than 10. So I'm asking you, is 0.8 greater than or equal to 1? No. Yeah. Good response. Great response. Glad you guys are answering my questions, even though I'm virtual. Okay? 0.8 is less than 1, so that's not happening. So what I need to do is I'm actually going to expand this, which I know seems counterintuitive, but if I have 0.8 and I move it to the right, 1, 2, 3, 4, this is 8,000, okay? Or it is 8 times 10 to the third. So 8,000 times bigger, or 8 times 10 to the third times bigger, is the table tennis ball than the neuron. Okay? All right? So, adding and subtracting with scientific notation. To add or subtract numbers written in scientific notation, it's helpful to write the numbers so that the exponents on each power have the same value. Okay? So essentially this means is like, as we were simplifying algebraic expressions early in the year, I couldn't add 8x squared and 8x together. Okay, that was a no-no. They didn't have the same term. They didn't have the same variable at the same exponent. Same thing with this. If I want to add and subtract something, I can't have them at two different exponents. So I need to kind of move things around to make sure that it has the same exponent so I can add and subtract. So here I have 1.45 times 10 to the 9th. Okay. Minus 2.84 times 10 to the 8th. So there's a couple different ways that we could do this, okay? What I'm going to do is I'm actually going to move this to the right one and make this 14.5 times 10 to the 9th, which I know isn't proper scientific notation, or 10 to the 8th, sorry. 14.5 times 10 to the 8th minus 2.84 times 10 to the 8th. Because what that's going to allow me to do here, okay, is now I can subtract that. 14.5 minus 2.84 is something we could easily do here. Okay, 14.5, 2.84, because that is 0. Okay, minus, borrow from here, becomes 10, 6, borrow from here, that becomes 14, 6, 11.66 times 10 to the 8th. Okay. Once again, this isn't in scientific notation, so I'm actually going to move this over 1 and increase this by 1. And it's going to be 1.166 times 10 to the 9th. Okay. We could have done the exact same thing by moving this over 1 and increasing that to 9. It really doesn't matter which way you do it. Okay. Looking back, I probably should have done that. Probably would have made this section here a little bit easier. But multiple different ways to do this. Okay? Main thing is that we have the same exponent as we add and subtract. All right, so your assignment's going to end up being page 271, problems 1 through 10. Appreciate you guys working with me through this week. I know it's not been the best. I know that it's kind of weird watching your teacher teach. It's not ideal for me either. I'm sitting here on Tuesday at 8:54 p.m. filming this last video. So I hope you guys have a fantastic week. You guys will have a chapter 4 review to work on tomorrow. This will be the last that you're seeing of me. You won't have to watch a video for the chapter 4 review. I hope you guys all have a fantastic weekend. Can't wait to see you guys on Monday. See ya.